Good morning, children. The first topic in today's class is representation of real numbers on a number line. What is a line? Geometry says that a point represents a position. If a point takes a straight path, that figure is called as a line, and thus a line is straight and can be extended on both sides infinitely, which shows that a line do not have a fixed length. A number line is a line in which the numbers are plotted at equal distances. Look into the figure 1 where you can see 0 is plotted. Next to 0, the consecutive number 1, 2, 3, etc. The distance between 0 and 1, between 1 and 2, between 2 and 3 is constant. That is, maybe a 1 centimeter in your scale. We take it as 1 unit. In this number line, you can see the fixed position as 0. The points are slightly apart, but still they are at equal distances. Maybe a 2 centimeter you have considered here as 1 unit, which means to say that when you plot numbers on a number line, the points should be at equal distances. We say it as 1 unit whether you consider 1 centimeter or 2 centimeter. And one more important concept is that since a line do not have fixed length, when you draw a number line, the position of 0 can be anywhere on the line. It need not be the center of the line which you are drawing. Coming to integers, if you consider a point 0, the positive numbers are bigger than 0 and the negative numbers are smaller than 0, which shows that the positive numbers will be plotted towards the right side of 0 and the negative numbers towards the left side of 0. From a number line, it's very easy to understand that whichever number towards the right of other number is always bigger, which shows that if you consider the two numbers positive 3 and positive 1, positive 3 is towards the right of plus 1 or 3 is greater than 1. In a similar way, when you consider the negative integers, minus 1 is towards the right of minus 3, which proves that minus 1 is greater than minus 3. After going through representation of natural numbers, whole numbers and integers on the number line, next is how to represent rational numbers on a number line. As an example, you are asked to represent 1 by 3 on a number line. You are drawing a number line. By the arrow mark shows that the line can be extended on both sides infinitely. You are plotting the 0 point. The concept is between 0 and 1, whatever be the unit or whatever be the measure you are taking, it has to be divided into 3 equal parts. That means as per the denominator. So when you are taking 1 here, you have to divide that 1 between 0 and 1. You have to get 3 equal parts by which the first point represents 1 by 3. The second point represents 2 by 3 and the third point represents 3 by 3 or 1. Thus, the point A represents 1 by 3 in this particular number line. Second example, represent 2 by 7 on a number line. By considering the denominator, after drawing the number line, take equal millimeters on your scale and start calling as 1 by 7, 2 by 7, 3 by 7, 4 by 7, 5 by 7, 6 by 7, 7 by 7, which can be taken as 1. So that further on, if they are asking you more numbers, like example, represent 13 by 7 on this same number line, you can proceed as 8 by 7, 9 by 7, 10 by 7, 11 by 7, 12 by 7, 13 by 7, 14 by 7 will be 2. In this way, if you consider the division of the measure between two consecutive numbers can be made easily, and you can plot the necessary rational number correctly on the number line. To plot 2 by 7, the point A represents 2 by 7, and to plot 13 by 7, the point B represents 13 by 7. The same logic follows in the case of negative numbers too. Represent minus 3 by 5 on a number line. When you draw a number line, since you have only negative numbers, the 0 can be plotted as to the right side here. The denominator gives you 5, which shows that the small divisions you can count as 1 by 5, 2 by 5, 3 by 5, 4 by 5, 5 by 5, which represents minus 1, or each point will represent minus 1 by 5, minus 2 by 5, minus 3 by 5, minus 4 by 5, minus 5 by 5, which gives you minus 1. Continuing till minus 10 by 5, you will get minus 2. If you continue further, you will get minus 3 and so on. Thus, to plot minus 3 by 5, minus 1 by 5, minus 1 by 5, minus 2 by 5, minus 3 by 5, the point A represents minus 3 by 5. So what does these points on the number line representing? What do the point B represent? What do the point C represent in terms of this number line? As real number system includes irrational number also, the irrational numbers square root 2, square root 3, square root 5, etc. can be plotted on a number line. That is, the value of square root of 2, square root of 3, square root 7 can be found out approximately from the number line. Consider a right triangle with base 1 centimeter and altitude also 1 centimeter. If you want to calculate the hypotenuse, by Pythagoras theorem, hypotenuse square is equal to base square plus altitude square, which is the same as 1 square plus 1 square, which is equal to 2, or the length of hypotenuse will be square root 2 centimeter. This will be the logic we will be using to find out or to plot square root 2 on the number line. Draw a number line and locate the point 0 on the number line. 2 centimeter length and plot that number 1. This is here your unit is 1 unit is equal to 2 centimeter. You have considered 1 unit as 2 centimeter and you are naming the point as A. You are plotting the point 0 or O, call it as O. You are plotting A. At A, you have to construct AD and it should be perpendicular to the length of OA. How to construct AD is the metallic point at A and an equal radius, you can cut 2 arcs, name it as C and D, C and B. With C and B as centers, the 2 arcs which you will be drawing will meet and this length what you are getting, that will be exactly perpendicular to the length OA. On that perpendicular, the same measure what you have taken as 2 centimeter with A as center and radius equal to 2 centimeter, you will get a point D which represents the perpendicular AD on OA. And now join OD. You got this length as root 2. How to project that length onto the number line? With O as center and radius equal to OD, cut an arc which will exactly plot onto the point F, or the point F will represent the root 2 and if you measure it will be approximately 1.41 etc. To make it clear, once again I will show you or I will explain the steps of construction. Draw a number line, locate a point O, locate another point A in such a way that the length of OA, it can be 2 centimeter, 3 centimeter and so on. Construct a perpendicular at A. On that perpendicular, you can take the length as the same OA. If it is 2 centimeter, it should be 2 centimeter. If it is 3 centimeter, it has to be 3 centimeter. You are locating the point D, which gives you the perpendicular AD. Now, once you join OD, this is 1 unit you have considered. This also is 1 unit. The same unit you have considered here, which shows that this length will be root 2 units. With O as center and the radius as OD, if you cut an arc on the number line, the point F will represent the point root 2. If you measure on the number line, you can see the measure will be approximately 1.41 etc. as root 2 is an irrational number. Let us represent square root 3 on the number line. Plot a point 0 or O. Take a length of 2 centimeter as A, another 2 centimeter as B. Get a perpendicular at A. Take a length as the same unit. You will plot the point D. Join OD. with O as center and the measure of OD, you will plot the point F, which represents square root 2. At F, construct a perpendicular the same length as you have taken here. That length need not change. It should not change. The length AD, it should be the same here. FG, join OG with O as center and OG radius. Again, if you plot, that will give you root 3. Thus, you studied how to plot root 2, root 3 on number line, how to represent root 5 on number line. But for root 5, the perfect square number close to 5 is 4 and square root of 4 is 2. So, you can start plotting the value, or you can start construction of perpendicular from the number on the real number line from the number 2, where the number 2 is plotted. This point represents the whole number 2. Again, whatever be the unit you are showing here, construct a perpendicular. On the perpendicular, this unit, you have to take it. Always join to the beginning point or to O or 0. This length will give you the value of root 5 with O as center and with the radius as OD. You can plot a point on the number line which represents root 5. The logic behind is, when you took as 1 unit and 1 unit, the hypotenuse proved as root 2 units. After getting the value of square root 2, you are again taking only 1 unit here and you are getting the value of root 3 by the calculation of root 2 the whole square plus 1 the whole square is equal to 2 plus 1, which is equal to 3. Again, with the value of 2, the same procedure for root 5, the right triangle with the length is equal to 2 units and height as 1 unit. You will get this length as root 5 units as 2 square plus 1 square is giving you 5. Or the value of this will be square root 5 units. Thus, the application of Pythagoras theorem is involved in plotting any irrational number on the number line.